In this video, we are going to learn how to identify a relative maximum and minimum. Now, we're going to have to use a graphing calculator for this because some of the techniques to do this without one involve a subject called calculus. So we're going to use technology to help us out here. But it's very easy to identify what a relative minimum and maximum are. They are the lowest point within a region, it would be a relative minimum, and the highest point within a region would be a relative maximum. Now, the reason why we use relative here is because this may be a relative minimum, but the graph certainly does go lower than that point. Same thing with the maximum. It's the highest point around here, but the graph over on the left does go above it. So we've only seen an absolute maximum or minimum with the quadratic so far because those were like the lowest points possible or the highest points possible. Now let's get into this problem here. Let's find the relative maximum and minimum of this given graph. So let's look at f of x to the third plus 3x squared minus 24x. So I'm going to hit y equals and plug that in. So x to the third plus 3x squared minus 24x. And I'll hit graph. And you can see here that my graph looks very similar to this one over here, but there's a highest point over here, so there's a relative maximum in that area, and then a relative minimum in this area at the bottom right. So how do we find these? Well, we can always use a table. So second graph, and you can look at these table of values and kind of see into the negatives, like it does reach like a highest point around -4. And it reaches like a lowest point around 2, and then it starts to go back up again. Or if you hit second trace, bring up the calculate menu, there is a minimum and maximum finding feature, and that's what we're going to use. So over in the top left was a maximum, so I'm going to hit enter, and we're going to find the biggest point. Now the way this works is I'll go to where the maximum, relative maximum is, and I'll go slightly to the left of it, so that gets my left bound. Then I'll go to the right of it, which gives me my right bound. I'll hit enter again. Then once you see these arrows are pointing towards where you want your relative maximum to be, or in between those arrows, you'll hit enter again to guess, and it'll guess the highest point possible, which is at -4, 80. So what we do is we say that the relative maximum is 80 at x equals -4. So again, the relative maximum is that number 80, and it's at the location of x equals -4. Now, if I want to know my relative minimum, I'll hit second trace and just go to the minimum option and do the same thing. I'll move my cursor to the relative minimum, which is all the way over here on the right, and I'll go slightly to the left of it, hit enter. Then I'll go to the right of it, I'll hit enter, and again those arrows are pointing inwards towards my relative minimum, so I'll hit enter one more time, and it's going to say it's at 1.999994 -28. So we say the relative minimum is -28, but it's going to be at, and that's basically 2 if I were to round to 3 decimal places. So I'll say at x equals 2. And that is how you find the relative maximum and relative minimum. Let's do it with another example, because here's some problems that can come up as we're looking for these solutions. If I hit y equals, I'm going to clear out that function, and I'm going to input 3x cubed plus x squared minus 5x. And I'll hit graph. And now I'll see my graph behaves a certain way, but that interesting spot where the maximum, relative max and the relative min would occur, it's harder to see because it's so small. So I'll need to adjust my window to include it. So right now it's going from -40 to 100 on my y-axis, but I want it to zoom in on the y-axis to show what's going on there. So I'll say it'll go from -10 to 10. So that's a lot smaller of a window there. I'll keep my x's the same. And when I hit graph, you'll start to see, oh, okay, here's that definition. I can see that maximum point and that relative minimum point. So now I will use my my second trace to find my maximum first on the left. Again, just go slightly to the left, slightly to the right, hit enter to guess, and this time I'll have a relative maximum at 3.132. So the relative maximum is 3.132 at x equals negative 0.865. Now you'll see here where the tables might not work out so well because it has these really long repeating decimals to really find that maximum. Now if I do second trace and do my minimum now, again I'll go over to my minimum, I'll go to the left of it first, then I'll go to the right of my minimum, then I'll guess, and it'll say that my relative minimum is negative 2.004 at x equals 0.642. Now let's use this in a word problem so you can see how you can start to adapt this to more real situations. So again, we have the design of a digital box camera maximizes the volume while keeping the sum of the dimensions at 6 inches. Now if the length must be 1.5 times the height, then what should each dimension be? So let's break this down. Let's say that x is the height of the camera. Now, following the statement, the length must be 1.5 times the height. So the length will equal 1.5 times x. And the width isn't given in that statement, but we do know that in total that all of the dimensions should add up to 6. So the width will be 6 minus x minus 1.5x. Because you want to take away the height and the length from 6. So the width will be 6 minus 2.5x. Thus giving us the volume, if it is length times width times height, to be equal to 1.5x times 6 minus 2.5x times x for the height. So now it brings us to this polynomial statement, which I'm going to simplify. So first I'll distribute the 1.5. So 1.5 times 6 is 9. So I'll get v is equal to 9x minus 1.5 times 2.5, 3.75x squared. And all that's times x. I'll distribute this x into the parentheses, and my volume is now negative 3.75 x cubed plus 9x squared. And I'll put that in standard form for the polynomial. So now we want to figure out what dimensions would give me the maximum volume. So this is my formula for volume. So I want to find the maximum. So I'll actually go to y equals and input this polynomial, negative 3.75 x to the third plus 9x squared. And I'll graph. So you'll see here that I get this nice polynomial, but I know I can't use all of those values, mainly because If the height of the camera were to be 6, there would be nothing left for the length of the width because it has to all add up to 6. And I also know that my height can't be 0 or something negative. So I'm actually between some chosen values here. So at least between 0 and 6, I only have one highest point. So what I'll do is I'll use my second trace, find the maximum of the relative, find the relative maximum of my polynomial. And I'll see that the relative maximum is 7.68 at x equals 1.6. Which really what that means is my max volume will be 7.68 inches cubed. Since I can't go any higher than that. It does go higher here on the left, but that's a negative dimensions for the x, which is the height, which can't happen. So what I'll have to do now is I know what the height should be. But I want to find all the dimensions to make this happen. The height will be 1.6 inches, but I want to find out what the length and the width will be as well. So to find that, I'll take 1.6 and I'll plug them into my length and width equations. So I'll do 1.5 times 1.6. Excuse me, 2.4. So the length will be 2.4 inches. And the width will be when I plug that into the width equation, which would be 6 minus 2.5 times 1.6. So 6 minus 2.5 times 1.6, which will be 2. So 2 inches wide. So it'll be 2.4 by 2 by 1.6 inches will be the dimensions. They'll give me the biggest volume possible. And that is how you identify a relative maximum and minimum.